4.4 is laws of logarithms. So we're going to take ourselves back just really quickly to think about the properties of exponents. So if you want, you can pause, see if you can write how we can rewrite these in ways that may help us. So when we multiply together things of the same base, we add our exponents. When we divide things with the same base, these expressions with the same base, we subtract the exponents. And when we raise something to a power to another power, so a to the m to the n, we are going to multiply our exponents together. So we want to remember that there's a relationship between exponential and logarithmic functions. So now we see the properties of logarithms that relate. There's some relationship there between what we saw with exponents and what we are seeing with logarithms. So notice if you have a logarithm with two expressions inside that are being multiplied together, you can split them apart using addition. That's what you're seeing here. So you can break them apart so that they each have their own logarithm with the same base separated by addition. The quotient rule is similar. You're dividing within the logarithm, so log base a of two things being divided can be rewritten where each expression inside has its own logarithm when you separate and with subtraction in between. And the power rule is something that's very useful to us. What I want you to notice is that we have a logarithm base a of x to the n, and what we can do with that n is we can go ahead and bring it to the front. So that's called the power rule. And now it's a multiplication, n times the log of something, log base a of x in that case. So now we're going to kind of practice using these logarithmic properties of logarithms, and I'll have this on each slide. But we're going to start by evaluating the expressions using laws of logarithms. So the idea would be to combine, to answer this question, log base 4 of 2 plus log base 4 of 32, to combine the two logarithms into one. So you want to think about do we need property number 1, do we need property number 2, or do we need property number 3? So think about which property we need for a second. And if you're thinking property number 1, you are correct. So with that equal sign, it's telling us that we can go either way. So in the first example here, we see something that looks like this. We see two logarithms separated by addition. That tells us that we can take it from here and rewrite it as one logarithm with that same base, but on the inside, we now have 2 times 32. And the point would be, maybe that helps us to simplify this a little bit. So we have log base 4, and then we want to do 2 times 32. Hopefully you recognize that that is 64. And then we want to remember that a logarithm is an exponent. So this is saying 4 to what power gives us 64. And whether you know what that is off the top of your head, or whether you do 4 times 4, 4 times 4 times 4, and see what you get, that's fine too. But it is actually 4 times 4 times 4. So 4 cubed is 64. If I rewrite it like this, it becomes very easy to see that my answer to this is 3. Realize that just by looking at what we have for the first couple things here, it would be very difficult to get that answer in the same way. So by rewriting it using the properties of logarithms, we're able to simplify. Now the next one, we have log base 3 of 27 raised to the 22nd power. So I want you to think about 1, 2, or 3 in terms of which thing here we're dealing with, which rule. Hopefully you recognize that we want to start with our power rule. We can take this 22, we can put it on the outside. So now it's 22 times log base 3 of 27. And then we just need to think about what is log base 3 of 27, which is saying 3 to what power gives us 27, because a logarithm is an exponent. So 3 to what power gives us 27, and we realize that this is an intermediate step if you want, but if we take 3 times 3, that's 9, times another 3 is 27. So 3 cubed. So there's a lot of 3's there, but it does tell us that our answer here is 3, because 3 to the third gives us 27. And then we can multiply 3 times 22 to get 66. And then we have done our evaluation. We've evaluated these logarithms by using these properties that we have. Now we can also notice the properties are still there. You have them right on your page. You don't have to worry about that, but I wanted us to be able to see them. So we can also do, conversely. So here we don't have numbers. Here we've just got variables, but we can do something similar in that, in this case, we have them as one logarithm here. And then now what we're going to do is we're going to write them in simpler logarithmic forms, which just means separating into different logarithms using our properties. So remember, we have property 1 and 2 and 3. So I want you to think about which property we want to use first here. Notice we have the natural logarithm. It's no different than any other logarithm except it has base e. So instead of writing log or log base something, I'll just write ln, and that will just, in my mind, I want to remember that that's log base e. So if you were thinking that we're going to use the quotient rule, you are correct. And what the quotient rule tells us is that we'll have ln x squared minus ln y cubed. So I can write it like this. I can put parentheses around the x squared, the y cubed, that's okay. But you want to remember that you can't have nothing in a log. You can't just have log. You can't have log base 5. Like that's not enough. Your logarithm has to have something in it. So we have one logarithm with an x squared in it and one logarithm with a y cubed. All we're doing here, though, is just seeing it using these properties. So now that we've used the quotient rule, I want you to think about what other property we can use. Hopefully, you're thinking about the fact that we have the 2 as an exponent and the 3 as an exponent, so we can be using our power rule. And it just tells us that we can bring that exponent over and multiply it, and we can bring that 3 over and multiply it. And so it's just breaking down this one logarithm into simpler logarithmic forms. So each of these other logarithms are simpler because they don't have exponents, and the thing inside is just one expression. If you want, you can try the next one on your own if you want to pause that and see what you can do, or you can come along with me. So we have log base a in this case, so logs can be any positive real number as their base. So I'm just going to keep that log base a. I'm just not going to lose it. I'm just going to keep it. So we have x squared, y to the 4th, and then we have this cube root. Anytime you see a root, you should think, that can be an exponent. I can rewrite that as an exponent. So we have a cube root. We can rewrite that as, think about what exponent that should be. Cube roots, in this case, is going to be a fractional exponent. So notice that's the whole thing raised to the power of 1/3. So I'm just rewriting that so that I can recognize that everything inside our logarithm has that exponent, and then therefore I can bring that exponent to the front and have log base a of x squared times y to the 4th. So all I did, use my power rule. Maybe I should do this because you're opposite me. The 1/3's going in the front. Now we want to think about, we've got this 1/3. Now we have something that kind of looks a little similar to what we had above, except we have multiplication with the two things inside the parentheses, the x squared, the y to the 4th, are being multiplied. But what we can do is we can separate those by using our product rule. So we can rewrite that as log base a of x squared plus log base a of y to the 4th. Notice I'm putting these big brackets because I want to make sure that both of those pieces need to get multiplied by the 1/3. Now that I've separated them, I don't want to forget that. And because I don't have any other parentheses, I can put it back. It doesn't matter, just notation. But now there is one more thing we can do. So if you take a look at the inside there, I want you to think about what's one more thing we can do. We have our power rule again, but it's for each piece. So the x squared allows us to bring down the 2, the y to the fourth, we can bring down the 4. Properties of logarithms. So we end up with this. Oh, well, I have to use the same one. I could use the regular parenthesis there. And then I can multiply through by my 1/3, which gives me 2/3 log base a of x, and gives me 4/3 log base a of y. So we're just simpler logarithmic forms, just practicing these properties of logarithms. A little bit more here. Now, suppose we're given this some information. So I want you to see that we're being given that log base a of 2 is 0.11. We don't know what the base is. It's base a. We don't have to worry about it. We don't care. Trust me. We also know that log base a of 3 is 0.2. We are given this information. Suppose this is true. Find log base a of 12. We're not given log base a of 12, but what they want us to do is to use what we're being given up here to break down that 12 into using these properties so that we can write it in a way where we see log base a of 2 and log base a of 3, because that'll allow us to do log base a of 12. So there may be a couple different ways to do this. But you could think about it as log base a of 12. You can break down 12 into 4 times 3. And you could even go further and break this down into 2 times 2 times 3. That's fine. Again, a couple different ways you could do this. You could also, I just want to kind of show you here, you could take what I have in my first line right here and write that as log base a of 4 using my product rule, log base a of 3. And then we don't know log base a of 4, but we know log base a of 2. And we know that 4 is 2 squared. Now I could have also gone from this line here and written it as log base a of 2 plus log base a of 2 plus log base a of 3. That would have been valid. I could have used the product rule in that way. Here I'm going to use the product rule, but then also the power rule. You get the same answer, I promise. You get the same answer here, so don't worry about that. Either way is fine, but it tells me that I'll have 2 times log base a of 2, and I'll have 0.20 to add to that. So it looks like I'll have 0.22 plus 0.20, so it looks like I'll have a 0.42. Now, this is not something you can check with a calculator, to be honest. It's not, because you don't know what the base is. It's base A. And you're not supposed to, you're just supposed to use the properties. If you'd like, I would suggest using, trying to see if you can do B here, log base A of 81. That would be great if you want to try it out, see if you can break down 81 in a way that helps you. There are a few ways to do this, but the easiest is probably to understand that 81 is 3 times 3, which is 9, times 3, which is 27, times 3, which is 81. So if you remember that, that's pretty much as far as we go with the threes. You could remember one more of that, but 243. But I'm just saying that 3 to the 4th is 81. So very quickly we can break down 81 into 3 to the 4th and then use what rule? And use that power rule. We're going to bring it to the front so that we have 4 times log base A of 3, which we know because that was given to us. And that gives us 0.80. Still using these properties here. So write the following expression as a single logarithm. So this is similar to the last one, it's just the opposite of what we did. So now we're taking things that are in these simpler logarithmic forms and combining them into one logarithm. So we want to work backwards from what we did before. And if you remember, one of the last things we did in the last ones was the power rule. So now we want to do the power rule first. So before I try to use the product rule or the quotient rule, I want to have it of the form where I have the log and then my exponent is going to head to where it belongs. So I'll have log base a of v to the fifth. You can probably see what the next one's going to be. Okay, so understand that when we're using the product rule or the quotient rule, notice there's nothing right here but a 1, there's nothing right here but a 1, there's nothing right here but a 1, there's nothing right here but a 1. Or a -1, I guess I should say. But the point is, the coefficient there is just 1. And so if you want to use the product rule or the quotient rule, you need to have it looking like that before you can use those rules. And so that's why I want to put the 5 here, that's why I want to put the 8 here, so that I have something that looks like that product rule. Now that it looks like the product rule, I can say, well, let's put everything inside one logarithm using that product rule, because I can do that since it looks like the right-hand side of that product rule. And then we just have that one logarithm. So that's our one logarithm example. And again, if you want, you are welcome to try the second one on your own and see what you get, and then unpause and come back together. So with this one, what I'm going to do is, which is pretty common, is I'm going to use the power rule first still, because I do have some power rule stuff happening here. But I'm going to deal with what I have inside my parentheses first. So I have ln x squared, and I have ln y to the 4th. So that's my power rule. And then I'm still working on that parenthesis because I have two logarithms. This is the natural log separated by the x squared. So I have ln x squared times y to the 4th. So if I want, I can put parentheses around that. Then I still don't have, like, I want to use that quotient rule, but I can't use that quotient rule yet because of this 1/3. If I want to use the quotient rule, I need to have just a 1 in front of the ln. So I need to use the power rule again now that I've combined everything inside my second logarithm here. So I'll have ln of x squared y to the 4th, and then that whole thing's going to be raised to the 1/3. Now, I can rewrite that if I want, because raising a power to a power, we can rewrite that as x to the 2/3, y to the 4/3, and then what I'm going to do is just to like give myself some more space here, I'll bring the whole thing up, and I'll have now, so again, this is all inside my parentheses. I have ln, then I have x divided by x to the 2/3, y to the 4/3. So that is one logarithm, but I have an x in the numerator and I have x to the 2/3 in the denominator. So if I'm going to write this as a single logarithm, I should not be seeing more than one of the variable. So we need to do x divided by x to the 2/3. And that's x to the 3/3. So I'm just, this is x to the 1. So I write it with a denominator of 3. So 3/3 is 1. X to the 2/3. And then I'm subtracting my exponents because I'm dividing two things with the same base. So that will give me still a fraction because I have that y to the 4/3 in the denominator. So I'll have x to the 1/3 divided by y to the 4/3, like that. So now I have natural log, ln, that's how we say it, and my one piece, my one expression inside my logarithm, it is now one single logarithm. Now, the last thing I'm going to mention is the change of base property. And what the change of base property says is that we can rewrite something with any base using the change of base property. So this is the idea. Right now we have log base 5 of 26. The answer to that is not a whole number. We know that log base 5 of 25 is 2, because 5 squared is 25. But log base 5 of 26 is not something we can come up with. Now, maybe I want to get on my calculator and I want to be like, okay, calculator, tell me what this is. But typically, your calculator will be very aware of log base 10 and your natural log. But most calculators, not all of them, but most calculators don't offer another base. And so because of that, the change of base formula can be helpful because it can allow you to rewrite your logarithm with a different base, typically so that you can evaluate it on a calculator. So notice that what it does is it takes and gives you a new base. So you pick your base. Most people pick log base 10 because it's what their calculator does. So you could pick log base 10, and then the thing inside the logarithm is up here, and the thing under the logarithm, inside, I should say the base of the logarithm, is down here. So if you want, you can take a second, see if you can rewrite this. So you're looking at it like this, rewrite it using base 10. It's pretty straightforward. It's just log of 26 divided by log of 5. And again, I don't have to write a base because I'm using base 10. And then I would just go on my calculator and I would say, okay, log 26 divided by log 5. And, I get some answer that of course is not pretty, but is very close to 2, which is not surprising. That's, makes a whole lot of sense. But what I want you to see is it works for any base. So if you decided, what, I'm instead going to use natural log, so base E, and I'm going to do this instead, and then you go to your calculator and you say ln 26, and you say ln 5, whoa, it's the same answer. And that's what the change of base property says, is that no matter what base you use, you should get the same thing. Base 10, base E are going to be the way to evaluate this on the calculator, since the answer is not going to be a whole number. So just to be exciting, I'll show you the proof of this. We have log base A of x. Let's say that that's equal to, for example, B. Now what we want to understand is that if I write this, what I'm saying is the exponent to which I raise A to get x is B, or A to the B equals x. Okay. Now what I'm going to do is I'm going to take the log of both sides with base B. So I'm going to have log base B of A to the B and log base B of x. One thing that we already know is that I can use my power rule and bring down the B, base B of A, log base B of x. And then if we divide both sides by log base B of A, we get B equals log base B of x divided by log base B of A. But we know what B is equal to. Don't forget that B is equal to log base A of x. So I get log base A of x equals log base B of x over log base B of A. And bada bing, we have just proven the change of base formula. All right, everyone, so I have the TI-30XS here just to show you. So I wanted to show you the change of base formula, and what we see is we have the log button here and the natural log button here. So they're very simple to use. If you want, you can create fractions on this. I do think it's a helpful thing to do. And the fraction button, as you can see, is just right here. So if I press the fraction button, I'm going to see a little fraction. And then I can put my log here, and then inside the log, I'll put 26. I can close it up. I go down, and then I press log of 5, and then I press enter. And you can see that I get my answer there just by doing that. So pretty straightforward. What I want to show you as well, which is what I just did, is that if I put the fraction bar again, I could instead use the natural log button and put 26, and then go down and put natural log. I do have to have the same base for this to work. And then when I close it up and press enter, again, I'm going to see that same answer. So that's how to do the change of base formula once you've written it out, how to do that in the calculator. And that is section 4.